Hi everybody, welcome to Unit 4, Lesson 2, Estimate Large and Small Quantities. Okay, so this is really the beginning of our scientific notation unit, which is how we write really large quantities or really small quantities. Okay, so large quantities could be like the magnitude of an earthquake. A really small quantity might be like the size of an atom, right? Something super tiny, all right? So, but in order to understand that, the first thing we need to understand is kind of like the relationship between place value and exponents. So we use something called a base 10 system, right? Which means like in each place value, there are 10 options for what you could put in each place value, which are the numbers 0 through 9, okay? So with that, with place value and exponents, we could say, all right, with 10 to the 4th, okay, that would be like saying 10 times 10 times 10 times 10, which even if we solve this, right, we have 100 hundreds, right, so that would be 10,000, all right, so 10,000, and notice there's 4 zeros right there, and there's a 4 in my exponent. Notice the exact same thing happens even with like 10 to the 3rd. We could say 10 times 10 times 10. Well, bringing that down, that's like 100 times 10, which is 1,000. Notice there's only 3 zeros. Same is true with 10 squared. 10 times 10, well, that's just equal to 100. Notice there's only 2 zeros. 10 to the 1st power, well, that just means I have 1 10. And notice there's only 1 0. Anything raised to the 0 power is equal to 1. Okay? And notice there are 0 zeros right there, right? Well, we can keep going. If we have -1, we go further into the place values, right? So, and 10 to the -2nd. Well, if this was 100, notice this is hundredths. That's where that comes from. That's where those place value names come from. Over here we had 100. Here we have hundredths. That the THS at the end, that signifies that it's past the decimal. Okay? So even here, over here we had 1 0, right? We had 10. Well, here we're in the tenths place value, okay? So they're related, and that's what we're going to be using. We need that initial understanding in order to complete scientific notation, okay? So in this first lesson, we're doing just this. We're estimating, okay? So number 1, what is a good estimate for this number? Okay, it's hard to say with how far down those place values go. And again, that's where knowing scientific notation can really help us. All right, so a good estimate, what I'm going to do is I'm going to look at that first place value, or like the highest place value, and I'm going to look to the right of it. Since this second number here is 5 or higher, that means this number that I'm estimating to gets bumped up 1. And then everything else after that would become zeros, or in this case, we actually don't need to include them. We can just leave it like this, okay? So the 2 gets turned into a 3, and everything else gets left off. I could put more zeros after there if I wanted to, but we don't need to, okay? Just like on this side, I don't need to put a million zeros over here, right? I don't need to do that over here. And on this one, I do have 4 example problems. All right, so hang tight. 2 of them, I believe, if I remember correctly, are from your quick check. So hopefully that'll be helpful. Okay, number 2. A total of 7,803,100 tourists visited country A, we don't know what country it is, from the year 2018 to 2020. round to the nearest place value, then express this number in the form of a single digit times an integer power of 10. Whew, that sounds complicated. Really what we're doing is we're writing it like in scientific notation, but it's not true scientific notation because we're doing the estimation first, okay? So if I'm rounding, let me rewrite the number down here, 7,803,100. Nearest place value, that just means that's like another way of saying like the highest place value. So if I'm going to round to my millions place, I need to look to the right of it. Since that value is 5 or higher, right? 8 is higher than 5. This gets bumped up 1, 2, and 8, and everything else after it becomes 0. They get left off. But in order for me to know that it's millions, right, I have to put zeros in there to hold their place value. So, this next part, once you get the hang of it, it's very, very easy, okay? But what I'm going to do, so it says, I'm going to write it in a form of a single digit, so that's like one place value in the ones place, times an integer power of 10. So in order to do that, what I need to do is I need to figure out, okay, well, how many, like going back to the place value, right? We did all those like 10 to the third power, 10 to the second power. Well, right now my decimal point is at the end of the number. In order to figure out how many, like what my exponent needs to be in my power of 10, I'm going to figure out, well, how many times am I moving my my decimal point? So 1, 2, 3, 4, 5, 6. And remember from our place value discussion, right, and the exponents, if it was 10 to the third power, there were 3 zeros. Well, if it was 10 to the second power, there were 2 zeros, and so on. Well, right now I have 6 zeros. So what I can do is I can rewrite this as 8 times 10 to the 6th power. Okay? So this would be my final answer. 8 times 10 to the 6th. If I were to actually solve this out, right? Well, 10 to the 6th power, that would be 1 million. And I have 8 of them. 8 times a million is 8 million. Okay? So, but really it's all about moving that decimal point. Number 3. How many times larger is 4 times 10 to the 4th than 2 times 10 to the 2nd? Well, what we can do to solve this is we can actually like use subtraction. Okay, we want to know how many times larger. Okay, I'm just going to, so right here, 10 to the 4th, there's a difference of 10 to the second power between those, and there's a difference of 2 between 4 and 2. So I'm left with a difference of 2 times 10 to the second power, which, if I solve that out, it would be 2 times 100, which is 200, giving me a final answer of 200 times larger. And our final question of the day, I have this giant number. Can you imagine like opening up your bank account one day and seeing that? That would be nice, wouldn't it? So this number, read properly, is $278,560,125,000. That's a lot of dollars. So first it says to estimate and then write in scientific notation. Okay, so we're going to use that same process that we did in number 2. Here's my nearest place value. So I'm going to look to the right of it. Since this number is 5 or higher, the 2 will become a 3, and then everything else after that becomes zeros. Okay? So this is an estimate. We could say this is about, oops, I forgot my last set of zeros. This is about 300 billion. All right? That's an estimate. But now what I want to do is I want to write it in scientific notation. So to figure that out, well, remember we're going to take that 3 and we're going to multiply it by a power of 10. And remember, that's just based on how many zeros there are. Or we could also consider it like moving our place value. In this case, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 zeros. So these are the exact same number, just written in 2 different forms. So 3 times 10 to the 11th power would be your final answer. And as always, if you need extra support, let me know, but I certainly hope this helps.